Okay, so far we discussed about the concepts of hybrid DBMS and the functions that Altibase H3 provides. Now in a final chapter called architecture. Okay, so this is the entire architecture of Altibase H3 shown as a diagram. As you can see, they are mainly divided into three main areas, and they are memory, thread, and storage. In memory area, there is something called memory data. This is the memory data space of Altibase H3, and this area is used for storing memory table spaces and also for memory tables. This area has the property name as memmax DB size. This property is set to 2 GB on default, and you can change the size from the configuration file called altibase.properties. And there's a buffer pool area. This area is for reducing the disk input and output from the disk data file. This area has the property name as buffer area size, okay? And it is set to 1 to 8 MB on default. Okay, the log buffer area, this area is used whenever the DML such as inserts, deletes, updates are executed. That information is firstly stored into log buffer area. So this is the first place where read log is saved into. This is based on the world protocol, write-ahead logging. Okay, meaning Altibase H3 records information into memory first rather than in a disk, which is to maximize the performance of the logging. Okay, this one last area in memory. This area is where the rest of the parts are saved, such as SQL plant cache, query process, main module, storage module, transaction, meta tables, dictionary information, store procedures, and so on. Okay, so this is where the rest of the informations are saved into. Now we're going to talk about the threads. Okay, so whenever there is a request from the client, let's say the query has been executed, then the dispatcher thread firstly detects the connection request from the client and establishes connection between client and the server, and also it delivers all the tasks to the server thread. Okay, once the connection is established, the server thread actually processes all the queries requested from the client and delivers the completed task. The load balancer is responsible for managing the task of server thread. Okay, but what it does is that load balancer actually add or remove the server thread. So when there are too much tasks for server thread, the load balancer makes another server thread to assist existing server thread. Vice versa, when there are not much tasks but the number of server threads are outnumbered, then the load balancer deletes some of the server thread to make it balance. The related property is called multiplexing thread count. This is the minimum number of server threads. On default, they are set to depending on the number of CPUs. Okay, so for example, when this property is set to 24, then the load balancer cannot delete the server thread not less than 24. Okay, there's also a property called multiplexing max thread count. This property is for the maximum number of server threads. If there are too much server thread, then the performance might be decreased. So this property has to be configured carefully. On default, it is set to 1024. The session manager is responsible for all the connections of the session, so it detects and processes all the timeout status of session. So when there's a timeout, the session manager actually detects and kills the session. The log anchor file, okay, like I explained before, this file contains all the information about databases such as recovery time, data file directory, DB startup info, the location of reader log file, checkpoint file information, table space information, extra control files such as boot file, message file, property file, and so on. Okay, this file is maintained by 3 copies, log anchor 0, 1, and 2. They are all the same and they are used for the recovery. So we recommend save this file into different directories for unexpected cases. Okay, the checkpoint thread. So whenever the checkpoint is executed, the checkpoint thread actually copies the memory data into checkpoint image file, which is stored in a disk. The checkpoint can be executed by interval, automatically by interval, for example, every 30 seconds, 60 seconds, 5 minutes, or 60 minutes, depending on the user's preferences. On default, it is set to 6,000 seconds. Okay, this has a property called checkpoint interval in second. Okay, checkpoint can also be executed by the number of log files is filled up. For example, every 50 log files or every 80 log files are filled up, the checkpoint is executed. On default, this is set to 100. The property for this one is called checkpoint interval in log. Okay, you can change these settings from Altibase properties file. You can manually execute checkpoint by typing alter system checkpoint command. Okay, the memory agent. This is related to MVCC, the multi-version concurrence control, but for memory only. Okay. So when there's a modifying operation, for example, update, the old version, the previous version of particular record is remain and a new version is created. This is to enable multiple statements accessing the same record at the same time so that they access the different version, even they're accessing the same record. Okay. So what memory agent does is that memory agent deletes the old version, the unneeded version of record when a statement executes commit or rollback. So the memory space can be retrieved in order to maximize the efficiency of memory usage. So when commit is executed, the old image is deleted. But when rollback is executed, the after image, the updated image is deleted. Okay, memory agent is also called garbage collector because it collects all the garbage. Okay, the checkpoint image files are the physical data file where all the memory data is safely stored into. Checkpoint image files are maintained by two sets of copies for the recovery. Checkpointing is also called fuzzy and a ping pong checkpointing. Okay, the fuzzy refers to the fact that transaction performance is not reduced during checkpoint, and the ping pong refers to the fact that checkpoint thread writes the memory data in two sets of checkpoint image file. So it's ping pong. It goes to the first one, goes to the second one, first one, second one. Okay, it's like ping pong. The checkpoint image files are used for recovery when DB starts up. These are named sys tbs mem data -0 -0 That's the first one, the second one, -0 -1. Okay, the two sets. The buffer flusher flushes all the modified pages, we call it dirty pages, to the disk data file. So whenever the page from the buffer is updated, they are flushed by buffer flusher, and the new page is also updated from disk data file as well. Okay. The log flusher records all the modified information saved in log buffer into physical log file. Okay. The log file manager makes the log file for the future use. Remember, read the log file for Altibase HTTP are sequentially created, so whenever they are filled up, they have to be switched to new empty log file. In order to do that, there has to be new log files ready. So the log file manager does their job. This has the property called prepare log file count, and on default it is set to 5. So the log file manager makes the log file depending on the number configured in prepare log file count property. The redo log files, where the information stored in a log buffer is saved by a log flusher. Okay. These files are also used for recovery. The log files are deleted whenever the checkpoint is executed. However, there is some number of cases that log files are not deleted. First of all, the log file contains the information about the ongoing transaction. Secondly, the log file is not archived into archive directory yet. Lastly, in replication, the log files are not sent to remote server yet. Okay, so those are the cases when read log files are not deleted. The archive thread is activated only when it's archive mode. Remember I said there are two different modes of database, the archive mode and non-archive mode. When it is archive mode, the read log files are copied into archive directory and they became archive files. The log files are archived when there is a log file switching, and there is a log file when there is a log file switching whenever the log file is filled up. So the archive log file is the copy version of log file saved in archive directory called arch, ALCH. Okay, the property file is the configuration file where you can do all the related configuration of Altibase HTTP. Okay, this file is called altibase.properties. Here you can check or change the properties related to buffer, memory, disk, replication, port numbers, and so on. Okay, the password file contains the encrypted password of sys user. The trace file can be used to monitor the status of Altibase HTTP. Here you can check all the errors about system failures and so on. Okay, the files such as Altibase storage module log, SM log, Altibase QP log, query process model, query process log, Altibase error log, Altibase boot log, log main module, log replication log, and you can check the related file depending on your situation.